7-Eleven down the street? No. McDonald's up on the corner? No.
Yes.
In that corner over there? Yes. Just saying. If I said yes and you left, I would have no legal recourse.
Okay. This one? Right there?
No, put it in power strip.
Oh, this one.
See that big white thing there? And with all the plugs in it? How come your iPad's not charged?
Because I forgot to.
LOS, Law of Sines, LOC.
Law of cosine.
Law of cosine. So you're asking yourself, self, what about the law of tangents? Where's that? Yeah, there's no such thing. This will be enough to keep you busy. It allows us to solve a simple problem. What happens if the triangle we're working with is not a right triangle? How do we handle this? And so I could go through the big, long, scary derivation of where law of sines comes from. And to give you a Reader's Digest version, what happens is you take this triangle and you drop an altitude and you split it into two right triangles, and then you write two equations for each of those, and then you bring it together, back together, and then all of a sudden you get this magic thing called the law of sines. We don't care about that. We just want to know how to use that bad boy. We're going to start with law of sines. And law of sines has one simple requirement. In order to use the law of sines, you have to know one angle and the side opposite that angle. If you don't have that information, then law of sines isn't going to work. Okay. So law of sines will work in this case because I know the angle measure of 47 degrees and I have the side opposite, which is 14. So law of sines will work just dreamily. Next question you might be asking yourself is, well, can I use this on a right triangle? Yes, you can. And in fact, some of you will start using law of sines on right triangles when you don't need to, but you know what? It's okay. You'll see why in a second. By the way, quick review. Somebody, Sarah, do us a favor. Type in the sine of 90 in there.
1.
Shazam. 1. Good. Anybody change anybody's calculator for the quiz, by the way? You guys are no fun. All right, so there's the law of sines. That's it. Now, there's two equal signs there. That doesn't make any sense. How do you do two equal? No, that's not. What is that mess? Well, you cover up the one you don't want. If we're dealing with angle A and angle B, then you cover up this guy. And I know that's not really covering it up. If you're not dealing with B, you cover that up. If you're not dealing with A, you cover that up, get rid of the equal sign, and go from there. The sine of an angle over the side opposite is equal to the sine of an angle over the side opposite. That's why we need the side opposite from an angle so we can get that ratio. Okay, here we go. Let's solve for x. Well, we know the law of sines will work because I already said it would, and we know an angle and the side opposite. So what would the law of sines look like in this problem, Matt?
It would look like, would it be sine 33 over x?
Equals?
Sine 47 over 14.
Hot diggity. That. Well done, Matt. Let's give it up for Matt, huh? All right, Matt, solve that bad boy.
Okay.
What mathematical technique do you think you would start with?
Would you start with cross multiply?
You bet you would.
Okay. So 14 sine 33 equals x sine 47.
Excellent. Not only did he demonstrate an excellent ability to cross multiply, but he was also clever enough to put the numbers in front of the trig values. Do you understand what I mean by that? He didn't say the sine of 33 times 14 because that would be sloppy math, because that could be mistaken as the sine of parentheses 33 times 14 close parentheses. We're waiting on you, brother. Yeah. So that's
There you go.
is that right? Okay. Are you looking for a snack or your calculator?
My calculator.
Oh, okay. What do you got, a Harry Potter bag there? Is that like infinitely deep? You got a whole arm in there? Or is it on the bottom?
I think it's on the bottom.
You think,
I hope it is.
right?
Because I put it on the chart. Give me a second. What? Oh, thank you.
Thanks.
This is
I was
awesome.
getting older. While he's calculating, and I know some of you have the answer, but let's talk about this logically without knowing an answer. Will x be bigger or smaller than 14?
Smaller.
Why?
It's opposite the smaller angle.
Yeah, I kind
It's,
of C.
C, like the angle C is smaller than angle B, so like the side across is always
Beautiful. Small, medium, large theorem. Yeah. When you're done solving these problems, you probably want to check the small, medium, large theorem just to make sure it's working correctly, because there is a lot of opportunities to screw up. All right, Matt,
10.42.
hold on.
No,
10.4
10.43.
10.43?
Yeah.
They like it. I only rounded to one decimal place. I don't know why, because I didn't listen to my own instructions. Any problems? Seems pretty easy, right? Same problem, kind of, different question. Now I'm looking for the angle measure. Set it up the same, solve it differently. Franny, what's the setup on this one?
Sine 25/5
Equals?
sine A/9.
Perfect. Solve that bad boy. Oh. We are currently experiencing technical difficulties. Please stand by. Nope, wrong button. There we go. What'd you say? Sine of 25 over what?
5
5 equals?
sine of A/9.
What'd you do first?
Cross multiply.
And got?
9 sine 25
Uh-huh.
equals 5 sine A.
Then what?
I didn't get part of that.
What's next, Julia?
I divided 9 sine 25 by 5,
Uh-huh. Divide both sides by 5.
and then I did the inverse sine.
Beautiful. So the 5s will cancel. I got sine of A is equal to 9 times the sine of 25 over 5. How do I get rid of the sine? As she mentioned, you do the inverse sine. If I do the inverse sine of one side, I have to do it to the other side. Careful how you type that into your calculator, because again, it's going to generate parentheses you might not have expected. One's going to show up there. You got to close that and do all kinds of fun stuff. What'd you get for A?
49.53.
I could go and do law of sines again to find angle B, but we're smarter than that. How do you find angle B?
Subtract from 180.
Yeah, subtract from 180. So 180 minus 25 minus 49.53 gives me 105 something.
0.47.
And those are degrees. Which again, I think my answer is probably only to the tenths. Theoretically, you should only have to do the law of sines set up once, because then you can go about finding the other sides. What you can't do, which some of you will, you can't use Pythagorean theorem. Why?
It's not a right triangle.
It's not a right triangle, that's right. Seems like a silly question, but I had to ask. Again, tenths place. I'm bad. Ooh, not a law of cosines. This will be fun. Oh, by the way, now I'll save it. I think we'll talk about it later in a second. Okay, law of cosines. Well, why would we have law of cosines? What happens, as it says up there, when you don't have that relationship of a side and the angle opposite? And that's going to portray itself in a couple different scenarios, which I'll outline in a second. Then you got to switch to law of cosines. This is a much nastier calculation, but the nice thing about it is you only have to do it once in a triangle. Okay? So there's a scenario. We don't know how big A is. We don't know how big angle C or angle B is, so we don't have the angle and the side opposite for the relationship. So we have to figure out a different way to do it. Okay. And we'll talk about the different scenarios for law of sines in a second after I give you that mess. Whoa. This is all the same formula. So before you start writing like mad people, let me show you how this works. Don't memorize these three things. It's all the same thing. The only thing you need to remember is that if A is on this side, then you're taking the cosine of angle A. And then the B's and the C's go in there. So if you have a triangle XYZ, and I have x squared equals, then the last thing I should have is cosine of angle X. This is just three ways of writing the same thing, depending on whether or not you're looking for one of the other sides. This one will be a little trickier to solve. But you're all smart, so I have the utmost confidence in your ability. And we'll start with the easier one. Oh, one other thing. Just to make your life a little bit easier, in fact, a lot of it easier, I should have included it, it just dawned on me. In your notes, please work. Oh. I don't know what I'm doing anymore. Okay, let's try that again. Go here. There we go. Put some parentheses there. It'll make your life a lot easier. Okay, we good? Let's try this. This is called a side angle side scenario because you have two sides and the angle in between. You know what side angle side means. You can recognize side angle side. This is the easier of the calculations. So we're looking for A first. A is opposite angle A. What's B? 4. What's C? 7. How big's angle A?
52.
52. Plug and chug, you get that mess. Now, the nice thing about this bad boy, you can type that whole thing into your calculator in one shot. Go ahead, practice. Don't forget the parentheses. You don't need those parentheses. I was just showing off. You put a times in there, you're fine. Don't forget you got parentheses around that 52 that might cause problems.
On the test, you want to, or the quiz, you want us to write this all out, right?
Yes. Because if you just give me an answer and it's wrong, then I got to take off all the points. If you give me a setup and the answer's wrong, then I can figure out what you did wrong and maybe partial credit.
Okay.
You don't necessarily have to show all the steps in this. In a side angle side scenario, set it up, plug and chug, and what do you get, Emily?
I got, well, I haven't square rooted
Okay.
yet, but I got a square equals 30.52.
Perfect. Okay, 30.52 something or another. Common mistake with law of cosines is you get the answer of 30.5, whatever she said, and you stop there. Notice that's what a squared is equal to. So then you have to take the square root of that answer and get?
5.52.
How do we feel about 5.52? All right, so I did the math. You don't have to. And you get 5.52, which again, I rounded to 2, one decimal place instead of 2. Okay. If I asked you to solve the triangle now, you could go back to law of sines and find all the other angle measures using law of sines. But you only have to do the law of cosines calculation once. Because now I know an angle and the side opposite, so law of sines would work. There is a small problem here. I'm going to have to use calculated information, which I've warned you about trying to avoid. We can't avoid it. So make sure you store that number in your calculator. And use the stored value, not the approximated value. Now, the reason the parentheses are there is when you see in the next scenario when we do the calculation, it's very common for people to take 49 minus 56 and go on from there. That's really bad math. We want the parentheses there. Okay? Easiest one, side angle, side scenario. Don't have the angle in the side opposite. Got to switch to law of cosines. And we have the side angle, side scenario for law of cosines. The bad one is the side, side, side scenario. 3 sides of a triangle. And you have a potpourri of possibilities. Sarah, what side would you, or what angle would you like to solve for first? D, O, or G? Oh, watch out for that.
Oh.
Oh, any particular reason? Beautiful. Tommy, which one would you like to solve for?
D.
Any other than the fact that it's not what Sarah picked? You would want to go to D? Jalen, how about you?
G.
Just because it's the one that's not picked?
Yeah.
But you have no real thought on why you picked G.
I like the number 12.
Why? Just like a favorite number of yours? Was it a uniform
know.
number of yours, or
Well, I like the number
days of
2.
Christmas, or what's the significance there?
I like the number 2. And 2's in 12.
Okay, so you would like the number 2000 also. I bet you would really like 2222.22.
How about 2 million?
About 2 to the 50th. Would that still work? Because that's 52s, but you don't list them all out. That would make you really happy?
Yeah.
Why do you like the number 2? At least you didn't pick 1, because that's the loneliest number. 2 can be as bad as 1. You guys have no idea what I'm talking about, do you?
Yeah.
It's an old song.
Are you saying Three's Company?
No, that's Come and Knock on My Door.
Mm,
We've
yeah.
been waiting for you. Where the kisses are hers and his.
Yeah,
Three's
yeah,
Companies too.
Yeah,
But that's T-O-O, not T-W-O.
right.
What? That's nice.
Three's Company 2, also. Three's Company also, not T-W-O, T-O-O. Right, you know the 3, T-O, T-O-O, T-W-O.
There's 3 types of 2s.
3 types of 2s, right?
I go
Like
to
there
the
and
store.
there.
Oh, yeah.
You with me?
Yeah.
Yeah. What are those, homophone, Never mind, this is math, not English.
Which one is your favorite 2?
Which one's my favorite 2? The one that looks like a 2? How many?
There's 2 though. There's 2
No,
There's
he's
three
like
twos.
like
There's three twos.
T-O-T-O-O.
Oh.
The one that looks like
I think I like T-O-O,
Why?
because it adds more to something, so you
Log
could
is
have.
1.
Plus, people usually use it wrong. Like they use T-O.
Oh god, that drives me crazy.
Yeah.
There and there is the one that drives me
That
insane.
one's, yeah,
Or
that one's
your.
really bad.
That one.
Yours.
Yeah.
Okay, so here's the problem. And you wouldn't know this other than the fact that I'm about to tell you. If you choose the angles in the wrong order, you can get wrong answers. So there's this weird thing called the ambiguous case of the law of sines. Doesn't that sound scary?
Yeah.
Yeah, we're not going to talk about it. It's so scary. You're going to save it for pre-calc when they talk about it. So we want to avoid the ambiguous case of the law of sines. And the ambiguous case of the law of sines takes into account the fact that you can get 2 answers. We don't like 2 answers. We want 1 answer and 1 answer alone. So we avoid that by remembering this stuff in red. We will always solve for the largest angle in the side, side, side scenario. Therefore, who is right?
F, no.
G.
Oh,
G is
really?
first.
Oh, whoever said O.
Sarah said O. Sarah wins. Right. If you don't believe me and you're bored tonight, then go and calculate this 3 different ways. Yeah, like at the dinner table, get the whole family around. You guys done with your Jell-O yet? Let's do some log cosines. Okay, so we're gonna solve for angle O first. We good? This one's gonna get a little crazy, kids. There's the setup.
That's ugly.
Who just threw up a little bit in their mouth?
I'm about to throw outside.
So we've got to get all this stuff over there and leave a cosine of O behind. This is not going to be fun. But it's doable. And you'll do it so many times it'll become second nature, like breathing.
Down it.
Ye of little faith. Okay, let's have some fun, Alex. You ready?
Yeah.
What would you do first?
I would do the exponents, the 12 squared plus the 8.8 squared.
Not horrible. I would say the only problem with that is that if you get big, scary, long numbers, then you got to continue to write those big, scary, long numbers down, or you have to store them. But doable. Okay, so let's assume you square them, and I don't remember what order I did this, so I'm afraid to click. What would you do next? What is 12.1 squared, by the way? Anybody got it handy?
146.49.
Okay, so that's a reasonable answer. We can work with that. Then what would you do?
Then I'll do the what's in front of the cosine O.
So you multiply these 3 numbers, the 2, the 12.1, and the 8.8 together.
Yeah.
That's also not a bad strategy. Okay, then what?
Then I'll subtract them.
Okay, be more specific than them.
Oh.
I'm not a big fan of
So,
pronouns.
Subtract the 12.1 squared plus 8.8 squared minus the 2 times 12.1 and 2 times 8.8.
Got it? Okay, so
What? But isn't it in like a parentheses, so you can't subtract that?
well, that's why he said if he multiplies this together, then he's got a nice number there.
Okay.
Okay, first things first. Take these 2 puppies, move them to the other side. Whether you want to square them first or not square them first, I don't care, but get them over there. 19.7 squared minus 12.1 squared minus 8.8 squared. You can simplify that if you want, or leave it as is. What's that going to leave behind? Ooh, that was a big jump. Hold on. We don't want to do that. Where's my pen? If I make that jump, I'll lose some of you, and then the tears will start. Right, Simon?
Yeah. I almost said one.
Okay, here we go. 19.7 squared minus 12.1 squared minus 8.8 squared is equal to, what's left behind? Okay, somebody tell me what's 2 times 12.1 times 8.8? Minus 30.
I did something different.
Good.
212.96.
Whoa. Whoa, not 30. I should have known that because I'm a math teacher. Negative 200 and,
12.96.
is that exactly 96?
Yes.
That's it. Okay, good. Times the cosine of O. Okay, that minus sign is really important. What next?
Divide.
Divide. So take this whole mess and divide it by negative 212.96. And negative 212 is going to leave me with that ugliness. And that's going to equal the cosine of O. Somebody tell me what that ugliness is, and just for giggles, put that in parentheses. Say again, I'm sorry.
164.24.
That whole thing?
Oh, no, just
No, okay. Then divide by negative 212.96.
2. Negative 0.
Wait. She's got it. I think she's got it.
Negative 0.77.
That's a horrible 7. 0.77. Give me one more just for giggles. 1. Can somebody confirm?
Yes.
Okay, now, here's a way to tell if you've made a mistake. That number that you get on the left-hand side, if you're dealing with a cosine or a sine, anytime you have, let's say, the cosine of some angle, let's say alpha, equals something, that number has to be between 1 and -1. So if I call this smiley face, then smiley face has to be less than 1, less than or equal to 1, or less than or equal to -1. If you get an answer like whatever that first one you said was 300 something or whatever, you did something wrong. Okay, that's good. Now what? Okay, how do we get rid of the cosine? Inverse cosine. So inverse cosine of that number, -0.771, which you have stored on your calculator, will give you angle O. And therefore angle O is equal to 140.46. Can somebody confirm?
Yes.
Yes.
140.46. Hot diggity. Are we good?
Yeah.
Now the big,
Oh, no. It's a,
It's
I have a question, but it's not about the problem. So I'll just ask it
you're not gonna ask me where babies come from, are you?
No, it's
Well,
about,
I'm not ready to answer that one.
okay.
Okay, good. Scared me. The more important question is, are you gonna be able to do this again?
Oof.
Barely.
All right, let's move on. So now we know angle O, and we want to solve the triangle. So I want to find angle D or angle G. Which angle will I do next?
Angle G,
Angle G, why?
because it's the next largest.
Next largest, so we're gonna go from largest to smallest. Okay, so I got that, then I got that, good. You rounded better than me, I'm done. So now to find angle G, given that we know angle O, we don't wanna do that law of cosines calculation again, because that's nasty. Let's switch to law of sines, because it's easier. Okay, and we get that mess. That was a big click, I'm sorry. Okay. Took the value that we have, which of course when you got an answer you stored it somewhere. Stored, you know, it was angle O, so maybe you stored it into O. It's getting kind of crazy there. The opposite side from that is 19.7. We're looking for angle G, and that's opposite the 12.1 foot length. Cross multiply. You get sine of G is 0.3907, which makes me happy because that's a number between 1 and -1, so this should work out okay. Get 23 degrees. You have O. Yeah. Yes, sir.
What do the 3 dots to the left of the D mean?
Great question. Can I come back to that in a second?
Yes, you can.
Thank you very much. Once I have O and I have G, how do I find D? Yeah, triangle sum. 3 dots means therefore.
Okay.
Okay, good. We haven't seen the 3 dots before?
No.
Oh, I thought I'd used that in the past. Okay, so if you have an angle in the side opposite, you go right to law of sines. If you don't, you have a law of cosines, and you have 2 scenarios for law of cosines. You have the side angle side scenario, which is easy peasy lemon squeezy, or you have side side side. And what do you need to remember for side side side?
Biggest angle first.
Say again?
Biggest side first, or angle first.
Biggest angle
Yeah.
first, correct. Okay, and then work your way down, biggest to medium to smallest. Now, when you're done, look at your triangle and see if it works. Okay. So we have angle O being 140.5, we have angle G being 23, and we have angle D being 16.5. Does that satisfy the small, medium, large theorem? Yeah, so there's a pretty good chance that we did it correctly. Lots of ways to screw it up, but for now, we'll assume that you did it correctly.
Equals 182.
And then, of course, March Madness is coming up. Yes, sir?
I tried doing the tangent of 90 because I was just curious, but it says
Correct.
How come it's not possible?
That's not an easy answer.
Okay. That's all I needed.
Well, we actually did answer that question already. Somebody else, why can't you do, let's go back one. Why can't you do the tangent of 90 degrees?
Oh, because isn't it equal 0? Or no?
Oh, there's no no, never mind, that's wrong. So there's no
Opposite. Oh, which one is it? You don't know which one's adjacent.
We don't know which one's adjacent.
Oh, okay.
So from a geometric standpoint, that's gotta be the answer. Tangent is opposite over opposite over adjacent. We got the opposite. Oh wait, that's also the hypotenuse. Okay, we can fudge through that. But then, do you use alpha or do you use beta for the adjacent? And since you can't, there's nothing that determines which one you use. You get an error.
Cosine is adjacent over hypotenuse, right?
Adjacent over hypotenuse.
Okay, but
Shouldn't
I
you
didn't-
know that by now?
No,
Or were
I'm
you
just-
testing me?
I'm just making
Did you think
sure.
I wouldn't know that?
No, I'm just making
I get
sure.
paid to know that.
I'm just making sure because I did cosine.
You're making sure that I knew it?
No,
I did know it.
I'm making sure that I know it. I'm just checking
And
with you.
hence my original question, shouldn't you already know that?
I should, but it doesn't hurt to check.
But I don't.
But I don't, right? That's all I was looking for. Was there a question in all this?
Yeah. If you don't know which one's the adjacent one, how come there's an answer for cosine of 90?
That's a good question. Not easily answered with geometry. Requires some higher level stuff.
Solve triangles and not.
Maybe we should just do what I said originally and stay away from that, because it's scary.